Good day and welcome to our lesson on applications of circle geometry. So the application we'll be looking at today is how particles going in a circular orbit act. What do I mean by that? I mean that the direction of movement, in other words the velocity of an object that is moving in a circular path, is always perpendicular to the center of the circle of its path. So that would mean, let's say if you had an object swinging around in a circle, if you were to let it go at an instant, then it would fly off at a tangent to the point that it was let go at. You can also think of this in terms of the orbit of the planets. Although the orbits of the planets are not circular, they're elliptical, they would move off at the same tangent to their elliptical orbit if, let's say, the sun just magically disappeared instantaneously. Alright, so let's get into an example. Let's say there's this fictional character, David, who is standing 6 meters to the right and 8 meters up from the corner of a building. He is swinging a rock tied to a string of length 2 meters. He let go of the rock when it was 7 meters to the right and 9 meters up from the corner of the building. Will the rock hit his friend Goliath, who is standing 2 meters to the right and 14 meters up from the corner of the building? So, looking at this, if we interpret the givens, 6 meters to the right and 8 meters up means that the center of our circle is 6, 8 relative to our reference point, which is the corner of the building. And since the length of the string is 2 meters, then that means that the radius of that circle is 2. So, if we wish, we could write the equation of the circle as x minus 6 quantity squared plus y minus 8 quantity squared is equal to 2. However, none of that is really necessary for our answer here. What we want to do is we want to find out, will that rock hit Goliath right there at G? So in order to do that, we need to find the equation of the tangent to the circle at the point 7, 9. So in order to do that, we have to first find the gradient of the normal, which is the point connecting D and 7, 9. The coordinates of D were 6, 8, which is where David is located. So to find the gradient, we use the gradient formula, substitute our values, we'll have 9 minus 8 over 7 minus 6. So 1 divided by 1 is 1. So the gradient of the normal is 1. If the gradient of the normal is 1, then the gradient of the tangent, which is perpendicular to that, will be -1. So to find the equation of the tangent line in slope-intercept form, we'll use y equal mx plus c. So when we substitute our values, we'll have 9 is equal to -1 times 7 plus c. -1 times 7 is of course just -7. Transposing, we'll have c is equal to 9 plus 7, which is 16. Therefore, the equation of the tangent line is y equals -x plus 16. So, will Goliath be in the path of the rock? The rock will follow that straight line once it is let go, because it is tangent to the circle at the point where it was let go. How do we find out if Goliath will be in the path of the rock? Well, in other words, we're just asking the question, does Goliath's position satisfy the equation y equals -x plus 16? To find that out, we simply substitute his current position, 214, into the equation and see if it satisfies it. So our equation is y equals -x plus 16. His y coordinate value is 14. His x coordinate value is 2. So we'll have 14 is equal to -2 plus 16. -2 plus 16 is 14. So since it satisfies it, then yes, the rock will go on that straight line and hit Goliath right in his forehead, I'm assuming. So with that, I'll say have a good day. See you in class.